Without graphing, determine whether the equation has a graph that is symmetric with respect to the x-axis, the y-axis, the origin, or none of these. The equation is 1 over x squared plus 1 over 2y equals 81. Okay, now, the graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. So the first thing we're going to do is we're going to replace, okay, y with negative y. Okay, let's do that. So here we're going to replace y to equal negative y. So we have 1 over x squared plus 1 over 2 times negative y, and we're going to say that's equal to 81. Okay, so what happens here? Well, we get 1 over x squared. Now this becomes a negative 2y. So if this becomes a negative 2y, then that becomes plus 1 over negative 2y, which is equal to 81. Now, we're going to now write this in the complete form. So this is 1 over x squared. Now, this 1 over negative 2y is the same thing as minus 1 over 2y, and that's equal to 81. So we need to know whether this equation is equivalent to this equation, right? Are they equal to each other? Well, the answer to that is no, because replacing y with negative y does not result in an equivalent equation, so the graph of the equation is not symmetric with respect to the x-axis. So we can see that those two are not equal to each other. So we'll just put a not equals there, okay, meaning that they're not equivalent. All right, now let's go ahead and then use the same equation here. Now it's telling us the graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. So what we're going to do here is we're going to replace x to be negative x. So let's plug it into this. So we have 1 over, we're going to plug in negative x, and then we're going to square it, and then that's going to be plus 1 over 2y, which is equal to 81. Now, after we simplify this, we have 1 over, well, if you take a negative x and you square it, well, a negative times a negative is going to be a positive. So we get 1 over x squared plus 1 over 2y, and that's equal to 81. So if we take a look at this equation here, and we look at the original equation, are they equivalent, meaning that are they equal? Well, yes, they are. So let's go ahead and write that statement. So this tells us what? This tells us that the graph of the equation is symmetric with respect to the y-axis, because if the replacement of x with negative x results in an equivalent equation. So therefore, we can see that it is symmetric with respect to the y-axis. Now, let's go ahead and check and see what happens if we want to find whether or not it's symmetric with respect to the origin. Now, in order to do that, we have to replace both x with negative x and y with negative y to see if we form an equivalent equation. So that means that x is going to equal negative x and y is going to equal negative y. So plugging that in, we have 1 over negative x squared plus 1 over 2 times negative y, and that's equal to 81. So what do we notice about that? We're still going to get 1 over positive x squared, but remember from the first step, this is going to be minus 1 over 2y, and that equals 81. So we're saying, is this equation here equivalent to that equation? And we say that it's not equivalent. So therefore, we're going to say that the graph is not symmetric with respect to the origin. So we would say that the graph is therefore symmetric with respect to the y-axis. So let's go ahead and then answer our question. So we say that it is with respect to the y-axis. Check our answer, and there is our result.